this tutorial, we will be dealing with numerical methods, particularly finding the root of a nonlinear equation using the method of false position or the regular falsi method.
Suppose we have a function f of x equal to y. We want to find the root or the value of x if f of x is equal to 0. To illustrate this method, we have here a graph. Then let's suppose the function looks like this. Then we will take this as our initial value, xi, while this one is our f of xi. Then this point will be our xi plus 1, and this one will be our f of xi plus 1. Then we will draw a line from f of xi to f of xi plus 1. Now we will look at the x-intercept of this line, and this will be our new xi plus 1. But in this graph, we'll use the subscript 2, so we won't get confused. Then this point here will be our new f of xi plus 1. Then again, we will draw a line from f of xi to our new f of xi plus 1, and look again at the x-intercept and repeat the process until the x-intercept is at this point, and that is our root of the equation. To compute for the x-intercept, xr is equal to xi plus 1 times f of xi minus xi times f of xi plus 1 all over f of xi minus f of xi plus 1. Let's take an example here.
For example, we have our function f of x equal to e to the negative x minus x. Then for simulation, first let our initial value xi equal to 0 and xi plus 1 equal to 1. Then the result is for x sub I, our f of x sub I is equal to 1, and our f of xi plus 1 is equal to negative 0.6321 for our first iteration. Then substitute again those values to the formula for xr. We will get 0.6127. Then substitute the value of xr to the equation to find f of xr. Now, we have to multiply f of xi times f of xr. If the product is positive, xr will be our new xi. If the product is negative, xr will be our new xi plus 1. So in our first iteration, since our product is negative, xr 0.6127 will be our xi plus 1. Then repeat the process until our stopping criteria is met. And the criteria for this one is that if the xr is repeated, then that is our root. So the final root is 0.5671.